Okay, in this lesson I want to try to introduce calculus, and eventually I want to get down to something called first principles. So what we're going to be doing in calculus is we're going to be looking at a curve, and we're going to be trying to find the slope of the curve, or the rate of change. Now there's two different types of rates of change. You have, if you're taking between two different points, and I draw a straight line, okay, that's going to give me my average rate of change. But if I want to, in calculus, I want to look at just the slope at a single point, the point along the curve at an individual point. And that's going to become my instantaneous rate of change. When I'm between 2 points, okay, and I draw a line between 2 points, that is called a secant. When I'm just connected to one point along the curve, that is called a tangent. Now I'm dealing with the slopes of this. Now slope, if you remember, is m equals y2 minus y1 divided by x2 minus x1. That is the equation of slope, and that is going to be something that is going to be important for us as we're moving forward. Okay? I'm going to want to find the slope of a curve at a point. And I'm actually going to find an equation for the slopes at all points along the curve. Okay? So a little bit of background knowledge here. First one is the slope formula. I need to remember the slope formula. M equals y2 minus y1 over x2 minus x1. Another thing that I need to be aware of is a little function notation. So usually you have y equals, let's say, 3x plus 1. But when you're dealing with functions, you're going to use f of x instead, equaling 3x plus 1. And if you change your input or your domain, you can change it. You can have f of a, where then my equation becomes 3a plus 1, a little function notation. You can have f of x plus 5 as your input, and then your equation becomes 3 bracket x plus 5 plus 1. Okay, so I start with my function, and you change your inputs, okay, and that changes the way your function looks. That's something to keep in mind. So I have function notation, I have the slope formula, and the fact that I'm going to try and find the slope of a tangent along a curve. Those are the things I want to keep in mind as I do this. Okay, so how am I going to do that? Well, let's take a curve. Okay, and I want to find the slope. So I need to have 2 points. Let's choose 2 points here. Okay, we're going to call this one x1, y1, and x2, y2. Because I'm going to want to find the slope between those two, which is, slope is m equals y2 minus y1 divided by x2 minus x1. Now that is a secant right now. Again, like I said, I want to find the equation of a tangent, which is an instantaneous point. Well, before I do that, I want to change these a little bit. Okay? These 2 points, I want to go in to do function notation. So instead of y1 and y2, I'm going to call it x and f of x, okay, is my first equation, where I just, instead of a y, I put in the f of x notation. Now this other point is separated. It's moved over. It's moved over from the first point by what's called h amount. So this second point, the x value, is actually x plus h. It's been moved over h amount from what my first x was. The y then would be f of x plus h. So I have my x value, I have my y value. I have my x value, I have my y value. The difference between the 2 points is called h. It's moved, the horizontal distance is moved over. So my slope formula now, okay, putting in my y2, y1, x2, x1, slope is going to equal f of x plus h for my y2 minus my y1, which is f of x, over x2 minus x1. Okay? Difference in the y values, difference in the x values. That gives me my slope. Okay, that's a good start, but we still have 2 points. Okay? I want to find the slope at an individual point. So let's choose what individual point I want to have. Well, let's choose this one right here. I want to find the slope at that point right there. So what I want to do is I want to take this second point and I'm going to start moving it back along the curve until I get very, 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 very close to that first point. I want to have my h value, the horizontal distance between the 2 points, start to shrink. And it's going to shrink very, 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 very close. It's going to get so close to it, it can't actually get right to it though, because I still need to have 2 points to let my slope formula work. So I want to have 2 points, but they're going to be extremely close together. My distance between them, which is h, is going to get very, very close to 0. The difference between them is going to get to 0. And I express that as being the limit as h approaches 0. The limit as the distance between them gets almost down to nothing. And so then I want to have these 2 points. They're going to get extremely close to 0. So in all, I have the limit as h approaches 0, f of x plus h minus f of x, or y2 minus y1, over x2 minus x1. Now, x plus h minus x. My 2 x's are going to cancel out there. And all I'll be left with is just an h. This becomes my formula for figuring out the slope, instantaneous slope, which basically becomes the tangent, because my 2 points that I'm using for the slope formula are so close together that they're basically just 1 point. This is the formula I'm going to use to try to find slope. Okay, that might seem pretty abstract. Let's try it with an actual function. So let's choose a simple one to start. Let's choose y equals x squared. Now again, I'm going to use function notation, so f of x equals x squared. Alright, so that is a parabola. I want to try and find an equation that comes up with a slope. So I know that I'm going to use a slope formula. y2 minus y1 over x2 minus x1. But I know that I have 2 points. They're separated by h amount. I know that the first function is x and f of x, my first point. And the second point is called x plus h and f of x plus h. First point, x1, y1, x2, y2. And I know that my h is going to get down to 0, because I'm going to move that second point right down, right beside the first point. Let its difference between them become 0. So the 2 points are very, very, very close to each other. And I express that as being the limit as h approaches 0. Okay, so using this, I'll just break down the formula again. I have y2 minus y1 divided by x2 minus x1. And then I'm going to actually use the notation f of x equals x squared. So that means limit h approaches 0. F of x plus h becomes x plus h squared minus my function, which is just x squared, divided by x plus h minus x. My x's on the bottom. My x and my minus x will cancel out. So all I'm going to be left with is h on the bottom. I still have the limit as h approaches 0, which just denotes that my 2 points are moving very, very, very close beside each other. The difference between them is becoming close to 0. I can do a little algebraic expansion on top. So x plus h squared becomes x squared plus 2xh plus h squared. You can do FOIL if you want to try and expand it. Minus the x squared. I have my x squared and my negative x squared are going to cancel out. So limit h approaches 0. So I have x squared and minus x squared are going to cancel out, and we're left with 2xh plus h squared divided by h. Now, with limits, you can put in the value you're trying to find and evaluate. But with limits, like we did before, if you have the denominator going to 0, that is a problem. And if I put a 0 in here, if I actually make the difference between them equal to 0, this fraction is going to go to infinity because I want to have a 0 on the denominator. So that's a problem. So I'm going to common factor out an h on the top. Okay, limit h approaches 0. When I common factor it out, then my h's will cancel out. Limit h approaches 0. And I'm left with 2x plus h. Now it's okay for me to put the 0 in. When I put the 0 in, I'm going to have 2x plus 0, or in other words, just 2x. What I have here is an equation for the slope, the instantaneous slope of a tangent along any point of a curve, of this curve. So it'll tell me the slope of a tangent. Now I can change my x value. If I want to know what the slope is when x equals 1, well, my slope is going to equal 2 times 1, which is 2. I can say x equals 2, and my slope is going to be equal 2 times 2, which is 4. This is an equation that tells me the instantaneous slope at any point along that curve. Now some notation. My original equation started off as f of x. This is not the original function anymore. This is an equation for the slope. So we're going to call that f prime x. It can also be denoted as y prime or dy over dx. That's what you want. Okay, let's quickly do one more example like this. And I'll do another quadratic, keep it simple. F of x equals 2x squared. Okay, so I know I'm going to have to take the limit as h approaches 0. I have already figured out the formula, f of x plus h minus f of x, and I know the bottom simplifies down to straight h. What I'm trying to find is called the derivative, which is the equation of the instantaneous rate of change along the curve at any point. And for that derivative, we're going to use a notation f prime x, meaning it's what my new function is going to be, the function of the slopes. Okay, this is my equation, 2x squared. Limit h approaches 0. I'm going to have f of x plus h is going to be 2x plus h squared minus my f of x, which is 2x squared, all over h. Limit h approaches 0. Now I could expand this, okay? So that's going to give me 2 bracket x squared plus 2xh plus h squared, okay? Minus 2x squared all over h. Again, I can do a little algebra on top here, so I can multiply the 2x squared, or the 2 into the brackets. Limit h approaches 0. 2x squared plus 4xh plus 2h squared minus 2x squared all over h. I cannot put in my limit right now because the h as 0 is going to make my denominator go 0. That's a problem. I need to do a little algebra first to get rid of that h on the denominator. So my 2x squareds are going to cancel out. I have a positive 2x squared and a negative 2x squared. They're going to cancel out. Limit h approaches 0. I got 4xh plus 2h squared all over h. Common factor an h from the top. H 4x plus 2h all over h. Limit h approaches 0. My h on the top and bottom will cancel out. 4x plus 2h. I can now put in h of 0 because my denominator is fine. It will not go to 0. So I have 4x plus 2 times 0, which will just give me 4x. That is the equation of the slope, also known as the derivative. And now I can put in a certain x value to figure out what the slope would be along my original curve. So if I want to find what the slope along the original curve is, let's say like x equals 5, the slope at 5 will be 4 times 5, which is equal to 20. There I found a slope of a curve at any given point. Thank you very much.